Okay, so now we're going to do experiment 2. This time we've changed the mass of the first glider slightly. We've put 4 25-gram masses onto it, and we'll find out exactly what the mass is in a second, and this one is exactly as it was before. So the heavy mass is now 242.6 grams. This should be exactly the same as it was before, but being good physicists, we will check. And indeed it is, 138.7. Okay, so that's going to be the stationary glider to start with. I will send the heavy glider down the track to collide with it, and we will take the measurements of the speeds. Have a look at the collision and see what happens afterwards this time, because it will be different from the first experiment. Ready? Off we go. You saw there that the first glider didn't stop completely, so we have to remember afterwards to take the momentum of that glider into account. Okay, so we've done the experiment, we've repeated it 3 times because we are good physicists, as you know, and these are the data that we've obtained. And just looking at them, you might wonder why there are 3 sets of speeds for each experiment. But if you think about it logically, that makes perfect sense, because when we set the first glider going, the second glider was stationary, so we will only have 1 initial speed, and then we will have 2 final speeds. This one is the light glider that went really quickly through the light gate. This is the second glider, the heavy glider, which slowed down in the collision, and so you can see there is a smaller speed for that one. Okay, so experiment 2, where we have the different masses, the large mass colliding with the small mass in an elastic collision. These are the data. You've got the 2 masses, we've got the first set of velocities, initial velocity, final velocity. Remember, the initial velocity of trolley 2 was 0. Same for the second, and same for the third. Now what you need to do is to use conservation of momentum and check to see whether or not momentum is conserved in this situation. Equation is there. I have actually done it, and if you work out for the first experiment to an appropriate number of significant figures, you should find that momentum is actually conserved.